Hello everyone, welcome to Gradeup. My name is Shantanu Sanwal. I am back with the course on strength of materials. In the last class, we have completed the topic of shear force and bending moment diagrams. And in this one, we will be solving the previous year's questions from the GATE examination of this topic of shear force and bending moment diagram. So first of all, about the free online GATE ME course, which is ongoing. It is designed by the GATE toppers and the experienced faculties. It has got a study plan of 90 days, which contains 200 plus video lectures and 250 plus quizzes for all the topics. And we are regularly conducting a live doubt sessions for the course. You can find the link of the course in the description below. You can subscribe to that course and start learning and start boosting your preparation for GATE 2019. So let us start with question number 1 that is asked in GATE 2015 set 3. What does this question say? Let us read. For the overhanging beam shown in the figure, the magnitude of maximum bending moment is. It is asking you the magnitude of the maximum bending moment in kilonewton meter. This is the overhanging beam. The BC is the overhanging section. The BC is the overhanging part. So first of all, we need to find out the reactions at A and B. So RA and RB. What will be that equal to? So this load total, this is the 10 kilonewton is the 10 kilonewton per meter is the intensity of the UDL, and it is acting for a length of 4 meters. So the total load that will be acting here will be 10 into 4, which is equal to 40 kilonewton. And that will be acting at a distance of 2 meters from here. 2 meters. So by using the summation of forces in the vertical direction equal to 0, what we get? RA plus RB, that is acting in the upward direction, equal to acting in the downward direction is 40 plus 20, that is 40 plus 20 equal to 60 kilonewton. This is the first equation. Then taking the summation of moments about A or B, I am taking about A, you can take it about B also, equal to 0, what will have? This load, that is the UDL of 40 kilonewton, that is now converted to the point load, acting at a distance of 2, that will cause a negative moment. That will cause a negative moment, which implies 40 into this length is 2 and this is minus. This will cause an upward plus RB into 4. RB into 4, and again minus 20 into this total distance from A is 6. And this is equal to 0. So this becomes minus 80 plus 4 RB minus 120 equal to 0, or 4 RB equal to 200, and from here you will get that RB is equal to 50 kilonewton. RB is 50 kilonewton. Substituting this RB equal to 50 at equation number 1, we will get RA equal to 10 kilonewtons. We have found out the reactions that this is equal to 10 and this is equal to 50. Now we have to find out the maximum bending moment. We take two sections. Let us consider two sections. Let us take one section here, that is the XX section at a distance of a small x from here, and let us take one section here, Y section, at a distance of y from this B point. So for the section X, for the section XX, the bending moment, the moment at XX will be equal to how much? See, this will cause an upward, that is 10 into x minus, now this is the distance x and the UDL is acting at a distance of x, the total intensity will be 10 into x, minus y, because that is will cause a negative bending, minus 10 into x, and that will act at a distance of, if you say like this, that this is 10 into x, this will be acting at a distance of x by 2 from here. So 10 into x by 2, which is equal to how much? 10x minus 5x square. 10x minus 5x square. Then you have to see at the point A, x equal to 0. So the moment at A will be equal to how much? Substituting x equal to 0, you will get 0. And at B, x equal to 4. The moment at B will be equal to how much? 10 into 4 is 40. Minus 5. 40 minus 5 into 16. Okay, this will be minus 40. Okay, so at A is equal to 0, at B equal to minus 40. Now you cannot go beyond this because we are considering only for this section xx. Okay, the other one we will consider for y. So for the section yy, what we will have? The moment at y is equal to, because of this 10, that is upward, 10 into 4 plus y, okay, minus this whole will be how much? This whole will be 40 minus 40 into, this will be acting at a distance of 2 from here because this distance will be also 2 because that will act at the center. So 2 plus y, minus 40 into 2 plus y, and then this one that will be again causing upward, that is plus 50 into y. So this will be simplified as 40 minus 80, that is minus 40, 10y minus 40y plus 50y. So 50 plus 10 is 60, 60 minus 40 is 20. So plus 20y. This is at y section. So at B, at means at which y is equal to 0, the moment at B will be equal to minus 40, and at C, at y is equal to 2, the moment at C will be equal to minus 40 plus 40, minus 40 plus 40 equal to 0. So from here you can see that the maximum bending moment occurs at B, which is equal to minus 40. It hasn't asked you the position, it has asked you the magnitude. The overall value is minus 40. Okay, that means it's a negative bending or a hogging bending, but this is asked you only the magnitude. So the correct answer will be here only 40 and not minus 40. So you have to see these kinds of words also, that magnitude is asked. If the maximum bending moment is asked, then you have to supply minus 40 because minus 40 and plus 40 makes a big difference in the NET problems. Okay, so the answer for this is 40 magnitude and the position is at B. Okay, next question.
Subscribe to our channel and press the bell icon to never miss any update from Gradeup.
2016 set 1, a simply supported beam of length 3L, the total length is 3L, is subjected to the loading shown in the figure. Okay, it is given that P is equal to 1 Newton. These are two P's, one is acting upward, one is acting downward. Okay, they both are of 1 Newton. L is equal to 1 meter, so the total length of this beam becomes equal to 3 meter. The Young's modulus E is equal to 200 gigapascal. The cross section is a square with dimension 10 millimeter into 10 millimeter. Okay, the bending stress in Pascal at the point A located at the top surface of the beam. Okay, now this will have the effect of positive and negative, because positive negative means a tension in the top fiber or the compression in the bottom fiber, whatever of that sort. So that is why it is written in the top surface. Okay, at a distance of 1.5 L from the left end, means at this point A, which is at the mid of the beam. Okay, indicate compressive stress by a negative sign and tensile stress by a positive sign. In this it has clearly been mentioned. Okay, so again the first thing is finding out the reactions. This is suppose 1 point, this is 2 point, so R1 and R2. Okay, so R1 plus R2 will be equal to plus P minus P, that is 0. This is equation number 1. Then substituting the means taking the moment about point A equal to 0, 1 equal to 0, what you will have? P into L, P into L is positive, minus P into 2L, minus P into 2L, minus R2 into 3L equal to 0, or you will have minus PL this will be plus R2 3L equal to 0, or R2 will be equal to P by 3. So R1 will be equal to minus P by 3. Okay, this you have got. R1 equal to minus P by 3 and R2 equal to P by 3. Then you have to find out the bending stress at a point A. So for finding out the bending stress, you need to find out the moment at A. So for finding out the moment at A, simply the moment at A will be equal to R1 is minus. Okay, that means the R1 is going in the downward direction. Okay, so simply you can write it in this way also. R1 into this distance is 1.5 L. Okay, if you take it plus, we will substitute the value as minus only. So if you are considering it going upward, so this will be a positive, this will again be a positive, plus P into 0.5 L. That's it, nothing more on that side. Okay, R1 is equal to minus P by 3. So minus P by 3 into 1.5 L plus 0.5 PL. So this will be minus 0.5 PL and this will be plus 0.5 PL. So this both will be equal to 0. So this is a very easy question, but the language that has been given or the things which are mentioned out here, that makes it a bit tricky. Just by finding out the moment at A, you see that the moment is 0. So if the moment or the bending moment at any point is 0, then there arises no question of having the stresses. So the bending stress won't exist at point A. Okay, so the answer is that the bending stress in this case is 0. There is no, and these all data that have been provided to you that indicate compressive by negative sign and positive, the tensile by positive sign, that is just to make you confuse. Because if you, what happens in an examination, if you solve such kind of a question and all these values have been given to you and you have done correct, you have arrived at the answer, correct answer, that is the 0. But then you will think or your question will come in your mind that all these values are given and I am getting the answer 0. So you will once again check this question and once again check your solution, and you will waste your 2 to 3 valuable minutes in again verifying the solution. And then also after the examination also you will feel somewhere that all these values were given and I was getting the answer 0. The chances are that I have done something wrong and my answer is wrong. But that is the thing which I am telling you. You must have faith upon yourself, and that faith will only come when you will be that much strong, or that much strong will be your preparation. If you have done rigorous preparation, if you have done rigorous practice, then even if all these confusing data have been given, the misguiding data have been given to you in any question of not only of this subject but of any subject, because these kind of questions are given because a person who isn't 100% sure about his practice or his his preparation, who is not 100% confident, will surely spend at least 1 or 2 minutes in re-evaluating his answer in this question, especially in this types of questions especially. Okay, so have faith upon yourself, have faith upon your preparation, and do not waste time in questions. You have solved the question very correctly, then what is the use of again wasting 2 to 3 minutes in again re-evaluating your answer? Okay, in that 2 to 3 minutes you could solve one more problem and that will fetch you more marks. Okay, so that is also one important point you should keep in mind, that do not fall in the trap of the examiners. Okay, this was basically a kind of a trap. Okay, so that you also have to, and that you will understand all these tips, that the tricks when you will solve as many questions as possible during your preparation. So solve the test series that we are providing you on Gradeup. We have an awesome test series, the mock tests, the full length, the part test, the subject test. Okay, so solve this and then you will have the idea that which kind of questions can be asked and at which point of the question you can feel that you are trapped. Okay, so how to get out of that that you will come to know while preparation and while practicing as many problems as possible. Okay, so that was a bit of advice. So let us see the next question. Asked in 2017, set 2. For a loaded cantilever beam of uniform cross section, the bending moment in Newton mm along the length is, the bending moment has been given, okay, where x is the distance in mm measured from the free end of the beam. The magnitude of shear force in Newton of the cross section in the cross section at x equal to 10 mm is asking. It is asking the magnitude of shear force. It's a very simple problem, I should say. M has been given to you, the M distribution has been given to you as 5x square plus 10x. Then the shear force F will be equal to, you know, it is equal to dm by dx, which is equal to 10x plus 10. Okay, then you are asking, it is asking the value of shear force at 10, x equal to 10. So just putting the value of x equal to 10, 10 into 10 plus 10, that will give you 100 plus 10, that is 110 newtons. So this is just a one-liner problem, nothing much to be done, just you need to know this, and then your answer is 110 in newtons. Okay, because this is given in Newton only. Okay, so the next question, GATE 2018 set 1. Simply supported beam of width 100 mm, height 200 mm and length 4 meter is carrying a uniformly distributed load of intensity 10 kilonewton per meter. Okay, the maximum bending stress in megapascal in the beam, okay, is, and that is asking up to correct to 1 decimal place. Okay, this is the beam that has been given. So the basic thing is, first of all, you need to find out the reactions. You know that this 10 into 4, the 40 kilonewton load will act at a distance of 2 meter from either end. Okay, so let us take this point as A, this point as B. So RA and RB. Okay, so simply RA plus RB is equal to 40, equation number 1. Then summation of moments about A equal to 0, that is 10 into 2, that will be minus 10 into 2 plus RB into 4 equal to 0, or RB will be equal to how much? 5. This is, oh sorry, this is, I did a mistake, this was 40, because this is 10 into 4 is 40. Okay, this one is 40 kilonewton load. Okay, so RB will be equal to how much? 40 into 2, 80 divided by 4 is 20 kilonewton. So the RA will be equal to again 20 kilonewtons. Okay, we have find out RA and RB. Then this is also 20, this is also 20. Just take a section XX at a distance of x from this point A, and just find out the bending moment at that section. XX will be equal to how much? 20 into x plus, means positive, minus, because this will, there will be a load acting like this, that will be 10 into x at a distance of x by 2 from here. Okay, so 20 into x minus 10x into x by 2 into x by 2. So this will be 20x minus 5x square. Okay, so the bending moment will be maximum at which point? This is the bending moment equation that we have got. Now we need to find out that the bending moment will be maximum at which point, because if you supply the value of x equal to 0, that is at A, and the x equal to 4 at B, so in both the cases, M at A and M at B, you will get that value as equal to 0. Okay, that value will be equal to 0. So for finding the point at which the maximum bending moment is there, because this is simply a mathematics, that a function is given and you have to find out its maxima. So for what you do, you just differentiate it with respect to the variable and substitute it equal to 0. So this gives 20 minus 10x equal to 0, or x equal to 2 meter. So the bending moment is maximum at x equal to 2 meters. Okay, so the maximum bending moment will be equal to, now substitute the value of x equal to 2 here, so 20 into 2 minus 5 into 4, okay, that will be 40 minus 20, that is 20 kilonewton meter. But this is not asked. It has asked the bending stress. So the bending stress, you know, the bending stress is given by m by z, where this z is the section modulus, okay, given by INA divided by Y max. Okay, now see, this is the rectangular cross section that is given. Okay, it is having a width of 100 and the depth as or height as 200. Okay, now see one important thing to be noted down here, that this bending is occurring on a vertical plane. This bending is occurring on a vertical plane. So if this is the beam, suppose this is the beam, this is the cross section of the beam. Okay, so this length, let us see this will be 100, this will be 200, and the bending will occur in a vertical plane. So the axis that will be perpendicular to that will act as the neutral axis. Okay, this will be the neutral axis in this case, neutral axis. Okay, so the INA will be equal to, let me write it down here, INA will be equal to 1 by 12, this length 100 into 200 cube. This you will get as 6.67 into 10 to the power 7 mm to the power 4. This is the value of INA. And what will be the value of Y max? The Y max will be equal to this value. This is 100 mm. So the Z you will get as INA by Y max, that is 6.67 into 10 to the power 5 mm cube. Now just substituting the value, the sigma B, m is this much, 20, but you have to change the value because it is asking in megapascal. Megapascal means Newton per mm square. So just converting the values in Newton and mm. So 20 into 10 to the power 3, converting this kilonewton into Newton, and mm again 10 to the power 3, converting this meter into mm. So this divided by 6.67 into 10 to the power 5, you will get this value as 30 Newton per mm square or 30 megapascal. So the correct answer here is 30, correct, to one decimal place, so you can write it as 30.0. Okay, or 30 is also the correct answer. Okay, so this is all what we finished in this. If you have any queries, any comments, write it on the comment section. If you like the videos that we are posting, so you have to like them, share them with your friends and colleagues, and also subscribe to the channel, that is by Gradeup. Till then, thank you, take care, bye.